Okay, welcome back to the dot cam. Now we have two pairs of homologous chromosomes, as you can see, to illustrate the law of independent assortment, which is alleles for different genes separate independent from one another. So right here we see we don't have our replicated chromosomes yet, so that's our first step here. So let's make sure that all of this genetic information gets copied. There we go. So now we have our homologous chromosomes here and here with the identical sister chromatids on each chromosome. So at this point, now we are ready to talk about metaphase 1, which is where this can be seen occurring, the law of independent assortment. So we know that metaphase 1 is where the homologous pairs of chromosomes are going to separate. So here we go, separate these homologous pairs. And let's see, the big F allele, so the purple flower allele, separated with the big B allele, and the little f, the white flower allele, separated with the little b allele. So that's one way this can happen. Another way this can happen, if we rewind and rearrange here, this could also happen. So separate them again. The big F allele could also separate with the little b allele, and the little f allele could separate with the big B allele. So the big F alleles, or like these chromosomes, are not influencing how these chromosomes line up and separate in the middle. They could do either way, it doesn't matter. So even though these are dominant, this is like the dominant allele, it doesn't have to separate with the other dominant allele. They could go either way, which is what the law of independent assortment states. Alleles for different genes separate independent from one another. And this leads to increased genetic variation in our gametes and eventually in any zygotes or children that are made. And think of this, so we're only modeling this with 2 pairs of homologous chromosomes. In humans, we have 23 pairs of homologous chromosomes. So this law of independent assortment leads to a crazy amount of genetic variation. So instead we need to line up 23 pairs up and down here to show how this happens in humans.